Hi everyone, I am Narayana, HOD of Mathematics Department from Delhi Public School, Bhimavaram. Welcome back to our online classes. Today, let us learn a topic, number systems. Before that, let us recall what we have learned in our previous classes. Under this topic, number systems, so far we have learned about different types of number systems such as natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Then we have learned about how to represent real numbers on the number line. Next, we have learned how to represent irrational numbers such as root 2, root 3, root 5, etc. on the number line using Pythagoras theorem. Let us learn some more about real numbers. In this class, we will see the real numbers and their decimal expansions. Already we have seen the real numbers are divided into rational and irrational numbers. Rational numbers which can be written in P by Q form, where P and Q are integers and Q is not equal to 0. Whereas irrational numbers which cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Yes, again we have seen that again rational numbers are classified into integers, whole numbers and natural numbers. This is all about real numbers, what we have learned so far. Next, decimal numbers you have learned in your earlier standards. Let us recall decimals. Usually decimals are classified into two types. One is terminating decimals and the other one is non-terminating decimals. Decimals are classified into terminating and non-terminating. Again, non-terminating decimals are classified into repeating and non-repeating. Repeating. Let us see some examples of terminating decimals. So I have written two examples. One is 0.125 and the other one is 1.002. Now let us see a few examples of non-terminating repeating, which are Example, (0.333 dot dot dot), which can also be written as 0.3 bar, or it can also be written as 0.3 dot. This is one example. Now, whereas non-terminating, non-repeating, which is one example, I will write 12.10 1100 111. So here I wrote one example, non-terminating, non-repeating, 12.10 1100 111 000, and so on. Yes, let us recall, in the previous classes I told you terminating decimals and non-terminating repeating decimals can be written in the form P by Q, where P and Q are integers and Q is not equal to 0. It means that I can write terminating decimals and non-terminating repeating decimals, these two kind of decimals, as a rational number, whereas non-terminating, non-repeating decimal you cannot write in the form of P by Q, where P and Q are integers and Q is not equal to 0. It means that non-terminating, non-repeating decimal is an irrational number. I hope it's clear from this pre-diagram. Now we will solve few examples which are rational numbers. We will do actual division and we will check whether the given rational number is a terminating decimal or non-terminating repeating decimal. After that we will see about non-terminating, non-repeating. Now let us see one example. Write the following in decimal form and say what kind of decimal expansion each has. The first rational number is 36 by 100. Now here the numerator is 36 whereas the denominator is 100. Whenever the denominator is either 10 or 100 or 1000 or 10,000, that is powers of 10, then you can write it in the decimal form directly. Yes, here you can see in the denominator 1 is followed by 2 zeros. So what I will do is, in the numerator, that is 36, I will start from units place. After 2 digits I will put the decimal point, starting from the least place value, which is units. So 1, 2. So it means that after 3 the decimal point will come. So 36 by 100 can be written in decimal form as 0.36, which is a terminating decimal. Yes. So what they said, write the following in decimal form. They have given rational numbers which are in the form of P by Q. We have to write them in decimal form. Then we have to say what kind of decimal expansion it is. Either it is terminating or non-terminating. Again in non-terminating, repeating or non-repeating. Yes. So this is one example. Let's go to the next example, which is 1 by 11. Here the numerator is 1 and the denominator is 11. So I cannot use the same method. Here the denominator is 100, which can be written as 10 square. It is a power of 10. So here 11 is not. So what I have to do is I have to use the actual division process. So here I will do normal division 11 1. Clear? So 1 will not go in 11 table, so I will start S. Now keep the decimal point. Here you have to write 0. Clear? 11. Zeros are 0 because 10 is smaller than the divisor 11. So 11 zeros are 0. When you subtract, you will get remainder as 10. Add one more 0. So 11 nines are 99. I got 1 as remainder. Now you can see S here remainder is 1. Here remainder is 1. Again you got remainder 1. Yes? So you can see it is 0.09. Again I will add 0. That becomes 10. Again 11 zeros are 0. When you subtract, you will get remainder as 10. Add 0. So again 11 nines are 99. The remainder is 1. First, let us look at the remainders once again. Here, the remainder is 1. Now here, the remainder is 10. Again, the remainder is 1. Again, the remainder is 10. Again, the remainder is 1. So you can see that we are getting remainders as 110, 110, 110. So in the quotient also you will get after decimal point 0909 dot dot dot. Yes. So 0.0909 dot 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 can also be written as 0.09 bar. 0.09 bar is a non-terminating repeating decimal. Therefore, 1 by 11 is equal to 0.09 bar is a non-terminating repeating decimal. Decimal. Now let's see one more example. Now it's a mixed fraction 4 1 by 8, which can be written as 8 fours are 32 plus 1 33 by 8. Yes. Now I cannot write directly because the denominator is not in form of 10 or 10 to the power. So what I will do is I will do the normal division. Here 32 will not go in 8 table exactly, so we have to go for 8 fours are 32. When you subtract, the remainder is 1. Yes. Now I have to add decimal point in the quotient, add 0 in the new dividend. Now this becomes 10. So 10 will not go exactly in 8 table. So I will take 8 ones are 8, and when you subtract, the remainder is 2 now. Next, I will add 0 to 2, then you will get the new dividend as 20. 20 will also not go exactly in 8 table, so I will take 8 twos are 16. When you subtract, you will get remainder as 4. Now add 0. Now that new dividend becomes 40, and 40 will go exactly in 8 table. 8 5s are 40. And when you subtract, the remainder is 0. Yes, therefore 4 1 by 8 can be written in decimal form as 4.125, which is a terminating decimal. I hope you have understood. I will take one more example. Here the rational number is 3 by 13. I will do normal division. Three. Yes, it becomes 30. 30 will not go exactly in 13 table, so I will take 13 twos are 26. Now the remainder is 4. I will add 0 to the right side of 4, then the new dividend becomes 40. 40 will not go exactly in 13 table, so I will take 13 3s are 39, and the remainder is 1. To this remainder 1, to the right side of 1, I will add 0. Yes, so 10 is a smaller than divisor, then I will take 13 zeros are 0. Now the remainder is 10. To this 10, to the right side I will add 0, then you will get 100. I don't have a place there, so I will do here. I will carry forward here. Now 100 will not go exactly in 13 table, so I will take a smaller than this. Let us see 13 sevens are. 13 sevens are is 91. When you subtract 91 from 100, you will get 9. To this 9 on the right side add 0, and the new dividend becomes 90. 90 will not go exactly in 13 table. Let's see, 13 6 are, which is 78. Now the remainder is 90 minus 78 is 12. To this 12, to the right side I will add 0. It becomes 120. 120 will not go exactly in 13 table, so I will take 13. Let's see, 13 nines are, which is 117, and the remainder is 3. Now to this 3, to the right side, if you add 0, you will get 30. You can see that will take you here. Yes, again you have to repeat this procedure. Now let us highlight the reminders, what you got. Here the remainder is 3. Here the remainder is 4. Here remainder is 1. Again here the remainder is 10. Here the remainder is 9. Here the remainder is 12. Now you got remainder 3. So what are the reminders? 3, 4, 1, 10, 9, 12. Then again you got 3. So it means that after 3 again you will get 4 as reminder. Again 1, again 10. So again in the quotient also these 6 digits which are in the decimal part will be repeated. So I can write dot dot dot, or I can keep a bar on all these digits. So 3 by 13, therefore 3 by 13 can be written in decimal form as 0.230769 bar, which is a non-terminating repeating decimal. Clear? Let us summarize what we have learned from these examples through our PPT. Real numbers and their decimal expansions. Yes, what we have seen through examples is the decimal expansion of a rational number is either terminating or non-terminating repeating decimal. Once again, through these 4 examples, we have seen that a rational number whose decimal expansion is either terminating or non-terminating repeating. I hope you have understood. Now, we will solve some more problems. Now let's see the question. You know 1 by 7 is equal to 0.142857 bar. Can you predict what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? Yes, here they have given the decimal expansion of the rational number 1 by 7. Let us write that in the answer. Given 1 by 7 is equal to 0.142857 bar. Here predict means without doing any calculations, like here 1 by 7, to write this in decimal expansion you have to do the division, long division. Now without doing long division you have to predict what are the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. If you express in decimal expansion, we have to say how. Yes, here To write all these rational numbers in decimal expansions, I will use 1 by 7, whose decimal expansion you can see here. I will use this. Let's see how. 2 by 7, let us consider. 2 by 7, I can write it as 2 into 1 by 7. Yes. Can we write? Yes. When you multiply a natural number and a rational number, you will get same thing, 2 by 7. I can write this 2 as 2 by 1. So, you know the rule for multiplication of fractions, multiply numerators separately and denominators separately, you will get same value. So, you can write 2 by 7, you can write it as 2, 1 by 7. Now, in the next step, now write the decimal expansion of 1 by 7, which you can see here. 0.142857 bar. Now, let us multiply this decimal with 2. Let us start. I will do horizontally only. You can do vertically as a rough calculation, but let's do. It's not that tough. 2 multiply with 7. 2 7s are 14. So 1 carry forward. 2 5s are 10. 10 plus 1 is 11. Write 1 here. 1 carry here. 2 8s are 16. 16 plus 1 is 17. So write 7 here. And 1 is carry forward. 2 2s are 4. 4 plus 1 is 5. No carry. Then 2 4s are 8. 2 1s are 2. Then you can see decimal point. Write the decimal point. 2 zeros are 0. Now keep the bar on all the digits in the decimal part. I hope you have understood. What I have done is 2 by 7. I wrote it as 2 into 1 by 7, which is nothing but 2 into the decimal expansion of 1 by 7, and multiply, find out the product of 2 and the decimal expansion of 1 by 7. I have done very clearly. So, and the final answer is 0.285714. On all these 6 digits you have a bar. I hope it's clear. Similarly, we will find out 3 by 7, 4 by 7, 5 by 7 and 6 by 7. Three by 7 is equal to 3 into 1 by 7, which is equal to 3 into, write the decimal expansion of 1 by 7, which is nothing but this, 0.142857 bar. Now I will multiply every digit with 3. So 3 7s are 21, 2 carry, 3 5s are 15, 15 plus 2 is 17, 7, 1 carry forward, 3 8s are 24, 24 plus 1 is 25, 5 I will write here, 2 is a carry forward, 3 2s are 6, 6 plus 2 is 8 and no carry forward here. Now 3 4s are 12, I will write 2 here and 1 carry forward, 3 1s are 3, 3 plus 1 is 4. Now you can see decimal point, so keep decimal point, 3 zeros are 0. Now keep on all the digits in the decimal part a bar. So 3 by 7 is written in the decimal expansion as 0.428571 bar. Next, 4 by 7, which is equal to 4 into 7, which is equal to 4 into 0.142857 bar, which is equal to, I will multiply every digit with 4. 4 7s are 28, 2 carry forward, 4 5s are 20, 20 plus 2 is 22, 2 carry forward, 4 8s are 32, 32 plus 2 is 34, 4 I will write there, 3 carry forward, 4 2s are 8, 8 plus 3 is 11, 1 I will write here and 1 carry forward, then 4 4s are 16, 16 plus 1 is 17, 7 I will write here, 1 carry forward, 4 ones are 4, 4 plus 1 is 5, then as usual decimal point, 4 zeros are 0, and this is the decimal expansion. Next, 5 by 7 and 6 by 7. So I multiply every digit with 5. So 5 sevens are 35. So 3 carry forward. 5 fives are 25 plus 3, 28. So 2 carry forward. 5 eights are 40. 40 plus 2 is 42. 2 I will write here. 4 carry forward. 5 twos are 10. 10 plus 4 is 14. 1 carry forward. 5 fours are 20. 20 plus 1 is 21. 1 I will write here. 2 carry forward. 5 ones are 5. 5 plus 2 is 7. And then point 0. Yes. So the decimal expansion of 5 by 7 is 0.714285 bar. And the last one is 6 by 7. Which is equal to, now multiply every digit with 6. 6 sevens are 42. So 4 is carry forward, 4. So 6 fives are 30. 30 plus 4 is 34. 4 I will write here, and 3 carry forward. Then 6 eights are 48. 48 plus 3 is 51. 1 I will write. 5 is carry forward. Then 6 twos are 12. 12 plus 5 is 17. 7 I will write here. 1 is carry forward. Then as 6 fours are 24. 24 plus 1 is 25. 5 I will write here. 2 is the carry forward. Then 6 ones are 6. 6 plus 2 is 8. Then decimal point, then 0. Therefore, the decimal expansion of 6 by 7 is 0.857142 bar. I hope you have understood. Here I have done, I got the decimal expansions of all these rational numbers without doing long division, using the decimal expansion of 1 by 7. Now let's go to the next sum. Now we will see how to write a non-terminating and repeating decimal in the form P by Q, which is a rational number, through our examples. Let's see, express the following in the form P by Q, where P and Q are integers and Q is not equal to 0. Here the first question is 0.6 bar. We have to write 0.6 bar in the form P by Q, where P and Q are integers and Q is not equal to 0. So we don't know. So let us assume 0.6 bar as x. Let x is equal to 0.6 bar. 0.6 bar can be written as 0.666 ... I hope it's clear. I will call this as equation 1. Now look at the decimal part. In the decimal part here 6, which is the only digit repeating, that 6 is called as period, and it is repeating only one time. 6 is the digit and it is repeating one time. Its periodicity is 1. Here the number of digits repeating in the decimal part is 1. So what we have to do is we have to multiply both the sides of equation 1 with 10. If 2 digits are repeating, then its periodicity is 2. So we have to multiply with 100. If 3 digits are repeating, then we have to multiply with 1000 and so on. Let us see here. Here only one digit is repeating. So we have to multiply both sides of equation 1 with 10. So on both the sides, yes, here you can just imagine 10 into this one, yes, 10 into x is 10x, which is equal to 10 into 0.6666. Already you have learned under the topic decimals, whenever you multiply a decimal with 10, 100, 1000 and so on. So here in 10, after 1, only 1 0 is followed. So we have to take this decimal point to the right side one place. So this decimal point will come here. So then it becomes 6.666 ... Now this is your equation 2. Call it as equation 2. Now what I have to do is I will subtract equation 1 from equation 2. Now subtract equation 1. X is equal to 0.666 ... This is your equation 1. Subtract them. Here the numerical coefficient of x is 10. Here the numerical coefficient of x is 1. So 10x minus x is equal to 9x, and which is equal to, start from here. Yes, 6 minus 6 is 0. 6 minus 6 is 0. So you will get in the decimal part 0, 0, 0, 0, ... And here in the whole part 6 minus 0 is 6. 6.00 ... is nothing but 6. Therefore 9x is equal to 6. Therefore x is equal to 6 by 9. 6 by 9 I can write it as in simplest form as 2 by 3. So in HCF of 6 and 9 is 3. So divide numerator and denominator with 3, or 3 2s are 3 3s are. Yes, and here x is nothing but 0.6 bar. Therefore 0.6 bar is equal to 2 by 3, where p is 2 and q is 3, which is not equal to 0. I hope you have understood, but still let us go through the whole problem once again. So let us assume 0.6 bar as x. 0.6 bar can also be written as 0.666 ... and call this as equation 1. Here only one digit is repeating in the decimal part. So multiply on both sides of equation 1 with 10. Then you will get 10x is equal to 6.666 ... Call it as equation 2. Now what you have to do is subtracting equation 1 from 2. what I have done here, you will get 9x is equal to 6.00, which is nothing but 9x is equal to 6. Therefore, x is equal to 6 by 9, which is nothing but 2 by 3. Therefore, I have written 0.6 bar, which is a non-terminating repeating decimal, as 2 by 3, which is a rational number. Now, let us see one more example. Here the decimal is 0.001 bar. Let us assume it has x. Let x is equal to 0.001 bar, which is nothing but x is equal to 0.001001 dot dot dot, and call it as equation 1. Here, if you observe, you can see that in the decimal part 3 digits are repeating, which are 0, again 0 and 1. As 3 digits are repeating, so we have to multiply both sides of equation 1 with 1000. So let us multiply left side. 1000 into x is 1000x, and multiply 0.001001 dot 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 with 1000. Here 1 is followed by 3 zeros. Therefore, the decimal point will move 3 digits to the right side. So here it will come 1, 2, 3. So it will come between this 1 and 0. Therefore, you will get decimal expansion as 001.001001 dot dot dot. Call it as equation 2. Next step is subtracting equation 1 from equation 2. Now I will write equation 1 here. When you write decimal, just take care of the decimal places. So 0, 0, 0, 1, 0, 0, 1 dot dot dot. This is your equation 1. Now we will subtract them, left sides and right sides separately. 1000 x minus x becomes 999x, which is equal to 1 minus 1 is 0. In the decimal part, you can see you will get only 0, and here 1 minus 0 is 1. Here you can imagine 0, 0 minus 0, 0, 0 minus 0, 0. So which is nothing but 1.0000, which is nothing but 1. Therefore, 999x is equal to 1. Therefore, x is equal to 1 by 999. Now let us substitute the value of x, which is 0.001 bar. Therefore, 0.001 bar is equal to 1 by 999. Yes. Hence, we have expressed the given non-terminating repeating decimal in the form of p by q, which is 1 by 999, where q is 999, which is not equal to 0. I hope you have understood from these two examples how to write a given non-terminating repeating decimal as a rational number. Now let's solve some more problems. Now I have taken one more example. In the decimal part, you can see in earlier two problems, all the digits in the decimal part are repeating. But here I have taken one example where one digit is not repeating and the other digit is repeating. Then what to do? Let's see. As it is also the same procedure. Now let us assume this as x. Let x is equal to 0.47 bar, which is nothing but x is equal to 0.4777 dot dot dot. Call it as equation 1. Here in the decimal part, 7 is the digit which is repeating and which is the only digit, so multiply equation 1 with 10 on both the sides. Then we will get this as 10x, and this as in 1 is followed with only 1 0, then you have to move one digit here to the right side, therefore you will get 4.777 dot dot dot, call it as equation 2. Next step is subtracting equation 1 from equation 2. X is equal to 0.477 dot dot dot, this is equation 2. Now subtract 10x minus x is 9x, and here 7 minus 7 is 0, 7 minus 7 is 0, 7 minus 4 is 3, decimal point, 4 minus 0 is 4, and again you can see 7777, so dot dot dot, which is, so you will get 0 0 0 dot dot dot, which is nothing but 4.300 dot dot dot, is same as 4.3. Therefore 9x is equal to 4.3. 4.3 I can write in rational form or fraction form as 43 by 10. Therefore now x becomes 43 by 10 into 9. Therefore x is equal to 43 by 90. Now let us substitute the value of x, which is, therefore 0.47 bar is equal to 43 by 90. Yeah, so I have expressed it in p by q form. Yeah, here in the decimal part 4 is not repeating, whereas 7 is repeating, but the procedure is same. I hope it's clear. First, let's read. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Yes? So, when you, here the given rational number is 1 by 7. When you do the long division, you will find out that 1 by 7, when you write in decimal expansion, it is a non-terminating repeating decimal. It means that there you will have a block of digits which are repeating. Now, what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 70? If you see in previous examples, yes, in the repeating part, either one digit will repeat or 2 or 3, yes, but that you can decide by looking at the denominator. Here the denominator is 17, therefore in the repeating block you can get minimum 1 or maximum it should be less than 17. So you will get maximum 16 block of digits which are repeating in the decimal part. Yes, let's see through our division. Perform the division to check your answer. So maximum how many? It should be less than your denominator, the divisor. So 17, so you will get maximum 16. It can be 15, 1, 2, 3 digits, but they said maximum, so maximum will be 16. Let's solve. Yes, again 17 zeros are 0. I will get 10 remainder, add 0, 100. Now 100 will not go completely in 17 table. Then 17, let's see, 17 fives are, or else I will write 17 table there for your convenience. Here I wrote very clearly. That will help you to do this division easily. So 100, I can see that 17 fives are 85. Now the remainder is 15. Add 0. 150. You can see 153. So 17 eights are 136. Now the remainder is 14, 4, 1. Add 0. Now the dividend becomes 140. 140 means again eights are 136. Now the remainder is 4. Add 0 to its right side. Now the new dividend is 40. 40 means 17 twos are 34. Now the remainder is 6. I will write here for my convenience. 6. Add 0 to its right side. Now the new dividend becomes 60. Look at 60 means 17 threes are 51. So threes are 51. Subtract. Now the remainder is 9. Add 0 to its right side. Now the new dividend is 90. Let's see, 90 will not go exactly. So I will take 17 fives out. So I will write 5 here. 85. Subtract. Remainder is 5. Add 0 to its right side. Now the new dividend is 50. Let's see here. 51 is there. So I cannot take. So again 2s are 34. Now the remainder is 16. Add 0 to its right side. You will get 160. Let's see, 160. 17 nines are 153. Now the remainder is 7. Add 0 to its right side. You will get 70. Yes. 70 will not go exactly in 17 table. I will take 4 times, which is 68. Now the remainder is 2. Add 0 to its You at the same time you just look at the reminders which I have circled. So there is no reminder 2. It means that I have to continue. Yes. So 20, that becomes 17 ones are 17. Now the remainder is 3. Check whether we got anywhere 3. No. So add 0 to its right side, you will get 30. So 30, now again 17 ones are 17. Now the remainder is 13. Add to its right side 0, you will get 130. 130 will not exactly go. We have 130, so 17 sevens are. It is 119. When you subtract, you will get remainder as 11. 1. Add 0 to its right side, you will get 110. Now let's see, 110, no. So I have to take 17 6, which is 102. When you subtract, remainder is 8. Now add to this right side 0, you will get 80. 80 will not go exactly, so I will take 17 fours, which is 68. Subtract it, you will get 12 as the remainder. Add 0 to its right side. Check whether you got 12. No. So it means that I have to continue. So 120. So I will take 17 sevens are 119. Now the remainder is 1. Let's check whether you got anywhere remainder 1. Yes, I can feel that remainder 1 is here. Yes, if I add 0, you will get 10. Again, yes, 10 means again 17 zeros are. So I will stop there, because it means that after 7, again 0, 5, all these will repeat. Let us count how many digits are there in the decimal part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Therefore, 1 by 17 is written as 0.0588239411767 bar. Yes, I hope you have understood. It's a lengthy division, but if you write the table next to you, you can do the division very easily. I hope you have understood. It's clear from this example. Now let us revise what we have learned in today's class. Yeah, today we have seen that the real numbers and their decimal expansions. As you know, real numbers are divided into rational and irrational. Yes. Now you know rational numbers which can be written in P by Q form, and irrationals which cannot be written in P by Q form. Yeah. The decimal expansion of a rational number is either terminating or non-terminating repeating decimal. A rational number, if you write in decimal form, you can observe that either it is a terminating decimal or a non-terminating repeating decimal, which we have learned through our examples also. In the coming class, we will see how to write decimal expansions which are of non-terminating, non-repeating, which are irrational. Apart from that, we are going to learn how to represent real numbers which can be written in decimal form to show them on the number line. Before that, winding up my class, I will give you some problems. Please solve it and mail to the given email which is on your screen. And if you have any queries, please give a call on the number which is on your screen. Today's assignment is, I will read once. First question is, write the following in decimal form and say what kind of decimal expansion each has. The first one is 3 by 13, second one is 2 by 11, and third one is 329 by 400. And the second question is, express 0.9999 dot 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 in the form P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. I don't think so right now it is possible to discuss with your classmates or your subject teacher. Yes, you can discuss with your parents or your brothers, elders who are in your home, and you can make sense of your answer. Thank you, and we will meet again in a short span of time.